Imagine a factory floor where machines don't just work. They think, adapt, and outperform humans. This isn't sci-fi. It's the robotics revolution, quietly reshaping the backbone of modern industry. These aren't just machines. They're intelligent systems, learning from every movement, every adjustment, every success and failure. They're not replacing people, they're enhancing human potential. What started as a niche industry is now a global force, driving innovation, efficiency, and a new era of manufacturing that's faster, smarter, and more sustainable than ever before. This is more than just technology. It's a transformation in how we create, how we compete, and how we imagine the future of work. Let's dive in. So, what exactly are we talking about? Let's start with the basics. Robotics and manufacturing. These aren't just machines. They're intelligent systems designed to perform tasks with precision, speed, and consistency. These robots are more than just automated tools. They're equipped with sensors, AI algorithms, and real-time data processing to adapt to changing conditions on the factory floor. But it's not just about speed. It's about accuracy. These robots are programmed to handle delicate operations, from welding to painting, with a level of precision that almost impossible for humans to match. And with the integration of AI, these systems can learn from their environment, optimize workflows, and even predict maintenance needs before a breakdown occurs. In short, robotics in manufacturing isn't just an upgrade. It's a complete transformation of how products are made, faster, smarter, and with fewer errors than ever before. You might not realize it, but every product you use, whether it's your phone, your car, or the appliances in your kitchen, was likely made with robotics. These machines aren't just replacing jobs. They're redefining how goods are made, faster, safer, and more efficiently than ever before. Behind every innovation in robotics, there is a deeper shift in how industries operate. Companies are now investing in automation not just for speed, but for sustainability, reducing waste, and optimizing resources, something that affects every consumer in the long run. When you think about the cost of goods, robotics is quietly shaping the price tags you see. Faster production means lower costs, which often translates to lower prices or better quality for the products you buy. Beyond cost, robotics is also making manufacturing safer. Dangerous tasks, like handling heavy materials or working in extreme environments, are now handled by machines, reducing the risk of injury for human workers. What you might not see is the ripple effect of this shift. From smarter supply chains to better product design, robotics is quietly transforming the way industries operate, and ultimately, how we live. Back in the 1950s, the first industrial robots were born out of a need for precision and consistency in manufacturing. These early machines, like Unimate, were bulky but groundbreaking, marking the start of automation's rise. By the 1970s, robotics had evolved from simple mechanical arms to more flexible systems. Companies began to realize that robots could handle repetitive tasks with unmatched speed and accuracy. The 1990s brought a wave of innovation with the rise of computer-controlled robotics. These systems were smarter, more adaptable, and capable of learning from their environments. Today, robotics in manufacturing is a full-blown revolution. From AI-driven predictive maintenance to fully autonomous production lines, the evolution is accelerating faster than ever before. The journey from clunky machines to intelligent self-learning systems has redefined what manufacturing can be. The future is not just about automation. It's about intelligence, adaptability, and seamless integration. Imagine you're building a toy car. You start with a big box of parts, and you put them together one by one. Now, imagine a robot doing that same job, but way faster, and way more carefully. Robots don't get tired, and they don't make mistakes like humans do. They can work all day, every day, without a break. That's why factories use them to make things faster and better. Even better, robots can learn from their work. They can get better and better at their jobs, just like how you get better at building things every time you try. So robots are like super smart helpers in factories. They make things faster, safer, and more accurate. And the best part? They're here to help humans do the jobs that matter most. Before any robot moves, the entire factory floor is meticulously planned. Every machine, conveyor belt, and workstation is mapped out with precision to ensure smooth flow and maximum efficiency. This layout isn't just about space. It's about integration. Robots must communicate seamlessly with each other and with human workers, which starts with a smart, interconnected infrastructure. At the heart of this setup is the programming and configuration of the robots. Each one is tailored to its specific task, whether it's assembling parts, welding, or inspecting quality. Sensors and cameras are strategically placed throughout the system to monitor performance and provide real-time feedback. This ensures that any issue can be detected and resolved before it affects production. Finally, the system is tested in a controlled environment to simulate real-world conditions. This step ensures that every robot is ready to perform with precision, speed, and reliability. Once the robot receives its instructions, it moves into position using a combination of gears, joints, and actuators to mimic the precision of human hands. Each joint is controlled by a motor, allowing the robot to bend, twist, and reach in ways that are both powerful and delicate, depending on the task at hand. These sensors feed data back to the control system, which adjusts the robot's movements in real time, making the process both efficient and adaptable. This level of precision and adaptability is what allows robots to handle complex, high-speed manufacturing tasks that would be challenging for human workers. The mechanism is the backbone of the robotic revolution, turning raw commands into seamless, high-performance manufacturing processes. Now, here's where it gets clever. The robot doesn't just move the part, it senses it. Using high-speed cameras and sensors, it reads the part's position, orientation, and even surface quality in real time. This data is sent to a central control system, which instantly calculates the exact movement needed. It's not just about where to go, but how to go there with perfect precision. This level of adaptability means robots can handle a wide range of parts without needing constant reprogramming. They're not just machines, they are intelligent assistants. And because it's all happening in real time, the entire process feels like a well-rehearsed dance. Every movement is synchronized, every adjustment is instant, and every part is placed with surgical precision. At the heart of it all is the science of motion control, how robots move with precision, speed, and accuracy. This is where gears, servos, and encoders come together to make manufacturing feel like magic. Sensors and feedback loops are the eyes and ears of these machines. They constantly measure, adjust, and correct, ensuring every movement is exact and every part is placed with surgical precision. Advanced materials and lightweight alloys are transforming the way robots are built. Stronger, lighter, and more durable. These materials allow for faster, more agile machines that can handle complex tasks. Artificial intelligence and machine learning are now being integrated into robotics, allowing machines to adapt, learn, and improve over time. This is where the future of manufacturing is being written. The science behind robotics is not just about machines. It's about collaboration. Between humans, software, and hardware, we're creating systems that are more efficient, smarter, and more powerful than ever before. Imagine a car factory where each worker has a unique job, but none of them know how the car is assembled from start to finish. That's how traditional manufacturing used to work. A complex, slow process with lots of handoffs. Now, picture a robot that knows every single step of the process. It can weld, paint, and install parts with precision, all by itself, without needing help from a human. This robot doesn't just do the job faster. It does it better, with fewer errors and less waste. It's like having a tireless, super smart worker who never gets tired or distracted. The difference isn't just in speed or precision. It's in the way the whole process flows. Robots don't need breaks, they don't make mistakes, and they can adapt to new tasks with software updates. So, in the end, the robotics revolution isn't just about machines. It's about rethinking how we build, how we innovate, and how we shape the future of industry. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.